This is Bob Davis 321 back with my oscilloscope project. That's the completed project. Turn on a light so you can see inside. There's the front panel. There's the analog to digital converter, the LCD display. Underneath it all is the Arduino that makes it all work. To wire up the front panel this way isn't all that great of an idea because technically the wires can affect the signal. And of course when you move the front panel around you lose the signal, so then I have to hook it back up. Turn off the light and we'll change our delay just to demonstrate the effectiveness of the delay change. Even slower. Back here and turn it back up. Yep, cause the wire to fall out again. We can change our wave shape over here on the waveform generator. There should be a square wave. That's a 20 kilohertz. I thought I ran that thing higher. Well, we'll run it up to 30 kilohertz. 1, 2, 3, 4, 5, 6, 7, 8, 9. 30 kilohertz. And we'll go here and we'll change the delay. Knock the wire out again. Actually, there's a delay of -1, which is 5 million samples per second. Hook the signal back up, and that's 30 kilohertz at 5 million samples per second. Turn that into a triangle wave shape. Or turn it back into a sine wave. Oh, why did my bias shift? That was a little weird. Anyways, there it is. The completed Arduino 5 million samples per second oscilloscope in 3 layers. It all fits in a, I think it's a 4-inch by 6-inch by 2-inch plastic box. I think it was from Radio Shack. And you have a Arduino powered oscilloscope.